Hello, my name is Gerald Whittle. I am the CEO of Whittle Consulting. In this video, I will give a high-level explanation of two concepts that underpin our approach to integrated strategic planning. These include activity-based costing, commonly known as ABC, and theory of constraints, known as TOC. At Whittle Consulting, when we build an integrated strategic planning model for the whole mining business, we apply these very specific techniques. So let's start with activity-based costing. Cost modelling in the mining industry in general is fairly simplistic. Costs are typically averaged, almost always based on tonnes, with little attention to how they behave when production goes up and down. That is what is fixed and variable. With conventional planning, where mining, processing and production rates are steady, this is okay. But in the optimised world, this will not do. We apply a special combination of activity-based costing and throughput accounting to develop a more advanced cost model to support the strategic planning process. This involves identifying the activities that are performed: drill and blast, excavate and load, haul, crush, grind, float, leach, smelt, etc. Identifying the drivers of those activities. What makes the cost of those activities go up and down from year to year? In particular, we want to tie the activity cost behaviour to the characteristic of the rock: density, depth, distance, fragmentation characteristics above or below the water table, the bondwork index, abrasiveness index, rheology, pH, viscosity, etc., etc. The real cost driver is almost never dry tonnes, which is what most mining cost models use as a base for all their costs. It's something else. Anything we can do to differentiate the costs of mining, processing and selling of different material in the ore body will improve the optimisation. Our software can handle this detail. We just need to tell it the truth about costs. Invariably, this knowledge always exists within the organisation. We just need to tease it out and make sure it gets into the strategic optimisation models. Calculating the revenue of a block is relatively easy. The grade times recovery times price. The cost to mine, process and sell it depends on 5 or 6 different characteristics. Depending on your process flow, tonnes and grades are only 2 of those. We're interested in the dollar value of the material in the ground. We're not mining gold, copper or iron ore. We're mining dollars, net value. That is the margin, which is the revenue of the block minus the cost of producing it. We find that 2 blocks with exactly the same grade can have very different cash margins. This is because they have different density, fragmentation, work indices, abrasiveness, pH, viscosity, etc., etc. Taking a dollar view of the ore body is fundamental to maximising value from the mine. At this point, you're halfway there. Now let's introduce theory of constraints. The next step is to look at the whole system. Theory of constraints is a management philosophy originated by Ellie Goldratt in the 1980s. Theory of constraints has been successfully applied in manufacturing and has a wide application for the mining industry. Theory of constraints tells us that every system has a primary bottleneck. That is the part of the system that most limits the performance of the total system. We've defined that the objective of the system is to generate cash. So we're interested in the bottlenecks to cash flow, which is not exactly the same as tonnes and grades. In mining, it is not always easy to identify the primary bottleneck, and just to complicate things, it's likely to move several times over the life of the mine. This is because the ore body changes as we work our way through it: stripping ratios, grades, rock hardness, etc. The principles of theory of constraints are completely applicable to a mining business, but the application of it's likely to be more complicated than a manufacturing plant where the TOC concepts were originally developed. We need to look at the ore body in terms of the net value, dollars, it contains, but not dollars per tonne. It must be dollars per bottleneck unit. It's important to identify where the dollars are and how fast they will flow through the bottleneck in the system. This is a whole new concept of what makes a mining business work, what makes it generate cash at the highest rate. Grade is not king. Net value per bottleneck unit is king. With a net value per bottleneck unit view of the ore body, we go back and re-optimise the pits, phases, underground, mine schedule, cut-off, stockpiling, blending, grind size, mass pull, product specification, logistics, and capital expenditure, which determines the bottleneck in the system that we create. The outcome can be a completely different view of where the value is in the ore body. The pit can move several hundred metres, the phases are different. So are the mining sequences, cut-off, policy, blending, etc., etc. It's a different world. We finally reveal the real potential to maximise the rate of flow of cash from the ore body to the bank account. The outcome can be dramatic. In many cases, the cash flow is doubled in the first 3 to 5 years. Same ore body, same plant, same assumptions, just a different conclusion on how to run the business. And the MPV increases 10, 20, 40, 60% or more. The system always had this potential, but we were blind to it by working in organisational silos, focusing on tonnes, grades, and maximising efficiency, utilisation, recoveries and reserves, and other superfluous activities. Since 1999, Whittle Consulting has successfully conducted over 150 enterprise optimisation studies around the world. Our results have repeatedly demonstrated that the comprehensive application of Whittle integrated strategic planning, incorporating activity-based costing and theory of constraints, improves the economics of a mining project or operation by 5 to 35%, and in many cases substantially more. These results are achieved even after conventional mining optimisation techniques have been applied.